In level 3, we will be using log properties to simplify and manipulate log expressions. So we're learning 3 new important properties in level 3. One is called the product property, and what this allows us to do is split apart a log. If you have something multiplied on the inside of a log, you can split that apart into 2 logs that are added together. And this follows from the exponent property where we multiply. Say I multiplied x to the second times x to the fifth. I add the exponents and get x to the seventh. So I'm multiplying, but I add the exponents. And same idea with this log. On the inside of the log, we have 2 things being multiplied. We split it apart into 2 logs that are added. So an example would be log base 5 of x times y. And I could split this apart into 2 logs, log base 5 of x plus log base 5 of y. The next property, the quotient property, kind of comes from the exponent rule where we divide. So if I did x to the fifth divided by x squared, I subtract the exponents and get x to the third. So I'm dividing, but I use subtraction with my exponents. Same idea with this quotient property. The inside part is being divided. I can split it apart into 2 logs that are subtracted. So if I had natural log of x over y, I could write that as natural log of x minus natural log of y. And the next one is the power property. The power property says we can take an exponent and move it to the front of a log. So like log base 5 of x squared is the same as 2 log base 5 of x. So we can take that exponent and just move it to the front, and that's an equivalent expression. And then the final property, the change of base formula, is a formula that allows us to get a decimal approximation using a calculator for a log that doesn't have base 10 or base e. We have buttons on our calculator for base 10 and base e, but any other base we don't have a button on our calculator. However, newer calculators do have a function that allows you to evaluate a log, and the change of base formula is not necessary on a newer calculator. So it's kind of something that isn't as important now as it used to be, but we'll show it to you anyways. And it probably won't be the big focus of level 3. The 3 top properties are the most important part. These first few examples in level 3 involve expanding a log. So we have one log with terms that are either multiplied or divided on the inside, and we're going to separate it into multiple logs. In this first example, I would split this apart to be natural log of 8, and since these are multiplied, I use addition plus natural log of x. And that's it. For the next one, again, these terms are being multiplied, so I'm going to split this into 2 logs using addition. I get log base 2 of x to the negative 2 plus log base 2 of y to the third. But now I'm also going to use my power rule and take my exponents and move them to the front of each of those logs. So I end up with negative 2 log base 2 of x plus 3 log base 2 of y. And the next one, there's kind of 2 ways to do this one. First of all, I want to write my radical as an exponent, and that is a 1/2 power. So this is ln of x over y to the third to the 1/2. And I can raise both x and y to the third to the 1/2 power and then split it apart, or I could move that 1/2 power to the front. I'll show both ways. So the first way, I'll move the 1/2 power to the front first. And then when I split this apart into 2 logs, that 1/2 is going to be in front of both of them. So I get 1/2 natural log of x, and then since we are dividing by y to the third, I use subtraction, so minus 1/2 natural log of y to the third. And my final step would be to move that exponent to the front. The 3 is going to be multiplied by the 1/2, and we get 1/2 natural log of x minus 3/2 natural log of y. The other way you could have done this is if you had just raised both of these to the 1/2 power right away, you would get natural log of x to the 1/2 over y to the 3/2. And then when you split it apart, you get natural log of x to the 1/2 minus natural log of y to the 3/2. Move both exponents to the front, and we get 1/2 natural log of x minus 3/2 natural log of y, which is the same thing we got using the other method. Now we are going to condense. We are going to take multiple logs and smush them into one log. Now they have to have the same base to be able to do this. So for example, in part A, they're both natural logs. So we can use this rule. And first, we're going to take the numbers in front and make them exponents. So I get natural log of x squared plus natural log of y to the third. And then to condense it or smush it into one log, since I have addition, I'm going to multiply the inside parts of the log. So we get the natural log of x squared times y to the third. And now I've condensed it into a single log. Same thing for this next one. First I'm going to take the number in front, make it an exponent, and we get log of xy to the fourth minus log of yz to the third. And, oops, I wrote this 4 in the wrong place. It needs to be out here. Okay, then I'm going to raise those to, or distribute that exponent to those terms, and we get log of x to the fourth y to the fourth minus log of y to the third z to the third. And now I'm going to condense it into a single log. So we get log of x to the fourth y to the fourth, and since it's subtraction, we use division, divided by y to the third z to the third. And then we simplify if we can, and we can simplify these y's. So we end up with log of x to the fourth y over z to the third. Feel free to pause me and try the last one on your own, but I will go through it. Same thing, take the number in front, make it your exponent. So we get natural log of x to the third y raised to the third power plus natural log of yz squared raised to the second. I'm going to do my exponent, natural log of x to the ninth y to the third plus natural log of y squared z to the fourth. And I'm going to smush it into one log. Since we have addition, I'm going to multiply these insides together. So we get natural log of x to the ninth y to the third times y squared z to the fourth. And then I simplify the inside, and we get natural log of x to the ninth. I can multiply those together by adding the exponents, y to the fifth, z to the fourth. The next part is also going to be condensing into a single log, but we are then going to be evaluating. We can't use our level 2 evaluating skills exclusively because, for example, Log base 2 of 144 is hard because 144 is not 2 to some power. So what we're going to do is condense it into one log and then see if we can evaluate or simplify. So we start with log base 2, and we're going to smush it all into one log. So the 144 goes on the top. Since I'm subtracting this next part, I divide by 72. And since I'm adding the next log, I'm going to multiply by the 16 on the top. Now, when I simplify this, since I'm not using a calculator for this, I don't want to actually multiply 144 times 16 and then divide by 72 because those are big numbers. So I don't want to deal with that. So I'm going to kind of use my old elementary schools of reducing. And looking at my numbers, 144 and 72, I know those can both be divided by 12. So if I divide both by 12, I get 12 and 6. And then 12 and 6 can both be divided by 6. I would get 2 and 1. So I end up with log base 2 of 2 times 16, which is 32. And now I can use my level 2 evaluating skills. This is log base 2 of 2 to the 5th power, which is just 5. Same thing for the next one. First we have a number in front, so we're going to make it an exponent. And I'm going to condense this into one log, so log base 5 of 10 squared, which is 100. The next one is subtracted, so I divide by 4. The next one's added, so I multiply by 25. And then I simplify. 100 divided by 4 is 25, and 25 times 25 is 625. And 625 is 5 to the 4th, so this is log base 5 of 5 to the 4th, which is 4. And last one, same idea, log base 3 of 4 goes on the top, times 6, and then divide by 8 because that part is subtracted. And this one we could do in our heads. 4 times 6 is 24, divided by 8 is log base 3 of 3, which is 1. The last part of level 3 is the change of base formula. This formula is log base A of B equals log of B over log of A, or natural log of B over natural log of A. And this is just a way to use your calculator to get a decimal approximation for these values. So log base 7 of 29, we don't have a button in our calculator for log base 7, so what we do is log of 29 over log of 7 using the log button, or you can use the natural log button, natural log of 29 over natural log of 7. When you plug this into your calculator, make sure you close the parentheses so it'll look like log of 29 divided by log of 7. And you get approximately 1.73. In the next one, same idea. Use either the log or the natural log button. So we would do log of 170 divided by log of 8, or you can use the natural log button. Get the same thing either way, and you get approximately 2.47.